Now that we've done the multiple regression in Excel, let's take a look at some questions that we might ask about the results. So the first one, where does it tell me what the x variables were? Other names for the x variables are input variables, explanatory variables, predictor variables. In machine learning, we often call them features. Sometimes we call them covariates. What we should avoid using is the term independent variable, even though that's really common in science and maybe in algebra class. That's partly because they might not be independent of each other, and also because the y variable in some sense depends on these x variables, and so they're not independent of each other. So anyway, where does the regression sheet tell us what the x variables were? Obviously not up here. It doesn't have any variable names. Here they are in the first column of the coefficients table. So that's what tells you what the x variables were. So in the first column, the coefficients table. And where does it tell us what the y variable was? Another name for y variable is the output variable, outcome variable, response variable, or target variable. And again, we should avoid using the word dependent variable there. So let's go look. We don't see the name. So our output variable was the average total SAT score. It's not listed here. It's not listed up here. Do we see it anywhere? It's buried right in there. It's the average, predicted average total SAT. So that's the column header on the second column in the residual output table. Let's write that down. So it says predicted, whatever the y variable. Where in the regression sheet does it tell us which sheet the data came from? We often will have multiple sheets that have data on them, sometimes slightly different versions or maybe different years. So let's go look at the regression sheet and see where does it tell us the name of the sheet the data came from. And the answer is nowhere. It does not record it at all. That means it is up to you to record it somewhere. You could click up here and type where it came from. Let's say teacher salary data 2. You should also name the regression sheet something reasonable, but you have more room here to put a full explanation of where it came from. So the answer is nowhere. It's up to you to record it properly. What if the data changes? We know that for trend lines, let's come over here and see our data. If I take one of these values and make it quite different just to make it easy to see, if I put in like 10,000 here, you can see the data graph updates, the trend line updates. Let's go see the teacher salary regression output. All these data, all these results are the same. You can trust me on that. Whatever one we made huge should now have a huge predicted value and a huge residual. So we saw no change. So that was changing a data point. What if we undo that and add a new state down here? We don't have to give it a name, but we could say $30,000 and 52% and maybe 1,002. And we can come back to the regression. It still says 50 observations, not 51. So that's unfortunate. Let's go back and undo that and record what happened. So it does not auto-update. You might hope there was a button to tell it to manually update, but there is no button. So there's no way to manually update. You just have to run the regression again. There are perhaps other plugins to Excel that will auto-update, but they aren't built in. There is something called the linest function will auto-update, but using it is kind of a pain, so ask me if you want to know more. What if there's a missing data value in the data set? So we could try here, I'll just try deleting that one, and we'll rerun the regression, data analysis, regression, okay. It remembers our settings, and we'll say missing data here, we'll hit okay. It says regression, linnest function returns error. Please check input ranges again. So basically, it cannot handle missing data. And in some sense, that's good because then you don't have to guess how it's handling the missing data. Let's come back to our questions. Gives an error from linnest. It basically can't handle missing data. Anytime we have missing data, we should be asking, is the data missing just kind of randomly, or are we getting missing data from maybe the low salary states but not the high salary states, or vice versa? So we should always be asking, is this data fully representative of the situation, and that includes how is there a pattern to the missingness. How many x variables can it handle? It turns out only 16, and that might seem huge for now. But there are lots of cases when we have dozens or hundreds of x variables, and so then we should use Python or R. What should we write for what the math model was? So maybe we'll come back to that. How should we make predictions for the model for new data points? So this was data from all 1 year. What if we got new x variables for the next year and kind of hoped that the same regression coefficients applied? How would we make new y predictions? There's no automatic way to do that. We'd have to write our own formulas. They aren't hard, but you still need to write them yourself. And then which variables are the most important? We can come take a look at the output here. And let's look at the coefficients in particular. So this is saying like 987 points plus 2.18 times average teacher salary plus negative 2.7-ish times the percent of pupils taking the SAT. It gives us standard error here, which is kind of like a plus or minus on the coefficient. So it's kind of 987 plus or minus 31-ish, as it's kind of like a standard deviation. It gives a confidence interval, and if you don't know what those are, that's totally okay. But this is saying like 98% of the time, if we had randomly sampled our data, the true coefficient or the true intercept would be between these two numbers. Again, take a stats class to learn more about that. It also gives us these t-statistics and p-values. A rough guideline is that if the p-value is less than 0.05, then we say the coefficient or the number is statistically significant. These are all less than 0.05, so they're all statistically significant. But the p-value is not directly a measure of how important a variable is. We could try to compare these two numbers and say, well, which one is bigger or farther from 0? But it turns out that's also not a good way, and we'll talk about that later. So we'll just say for now which variable is the most important. It's complicated, involves standardizing variables before regression. We're doing something called lasso or ridge or elastic net regression, which we'll talk about later.